In today's video, we're going to look at the properties of logarithms and using these in order to rewrite some of these logarithm functions so that they are easier to calculate. So I'm going to go through the 6 different properties that we have of logarithms. The first one is called the identity property, and that states that log base a of a is equal to 1. That makes sense because if I take my base to the power 1, I get itself. So a to the 1 equals a. Okay. The second thing that I have is my first inverse property. And that states that log base a of a to the x equals x. That makes sense, okay? A logarithm asks us what power do we have to raise our base to in order to get the argument. So I raise a to the x power to get a to the x. Okay. This also makes sense. It's called the inverse property. It makes sense because remember, a log base a is the inverse of that exponential function with that same base. So this is why we get this inverse property. Then we have the second inverse property. And this uses the exponential, and we looked at this in a previous video, where I take a base of a and then I take that to the log ax power and I get x. Okay. Again, this is because logarithms and exponentials are inverses of one another. The next property that I have is called the exponent to constant power. Okay. What this says is that if I have a log base a of b to the power c, what I can do is this power that I have of c, I can actually bring it out of the front of the logarithm to leave me with c multiplied by log base a of b. So I can bring that power down out of the power to the front of my logarithm. This is very, very useful both ways around, okay? It can help us simplify logarithms, and it can also help us expand them, as we'll see in some of our examples later on. Next, we have the product property. And the big thing with this, and also with our next property, with the quotient property, please make sure that you get these the right way around. Okay. What this says is that if I have a log base a of 2 numbers multiplied together, u and v, okay, I can actually split this up as log base a of u plus log base a of v. A lot of people get this wrong, and I want to make sure that we don't get this the wrong way around. Some people do this addition and product the wrong way around. Make sure you do not put this. Okay. A lot of people see product property and they think that we do the addition inside the log and then that equals 2 logs multiplied together. That is not correct. Please do not do that. This is the property that you want, okay? That log base a of 2 numbers multiplied together is equal to the logarithms of each one added. Okay. And like I said, the last one that we have is called the quotient property. And again, make sure that you get this the right way around. We're doing the logarithm base a of u divided by v is equal to log base a of u minus log base a of v. Again, a lot of people try to turn this around and say that it's log base a of u minus v, so that we're subtracting inside the log, and then do log base a of u over log base a of v. Again, that is not true. So please make sure that you do the division inside the log, and that equals 2 logarithms subtracted from one another. Now I'm going to do an example of some of these and make sure that we can use these all together in a particular example. So what I'm going to do here is I'm going to do 3 log base 4 of 2 plus 2 log base 4 of 5. Okay. What I want to do here is I want to use those properties that we went through to combine these into one logarithm. The first problem that I have is these constants at the front of my logs. Okay. What I really want to do is to make them exponents again, because I can't add anything with those being in the front of the logs. So I'm going to go backwards on this and actually put them back in as exponents using my exponent to constant property. Okay. Then I've got this addition of 2 logs with the same base. That means I can combine them now into one log and multiply those values that are in my arguments. So I'm going to have a log base 4 of 2 to the 3 multiplied by 5 squared. So now I can simplify this as log base 4, 2 to the power 3 is 8, multiplied by 5 to the power 2 is 25, and 8 times 25 is just 200. So now I've used all of those properties to combine them into one log function. You'll notice in this example that I took multiple different logarithm expressions and they had a sum or difference in them, and then I simplified them into one logarithm. You can also go the other way, so you can take one logarithm expression and then expand it out into multiple different logarithm expressions that are added or subtracted from one another. This will come up when we go ahead and solve some of our logarithm equations, as we will do in our next video. But let's go ahead and now do an example. I'm going to do this with just algebra. So I'm going to have x's and y's in here. Okay. I want to expand out this logarithm. Okay. This is going to involve quite a few of our different properties that we had. So my first thing that I'm going to do is to get rid of this quotient. So I'm now going to expand this as the difference of 2 different logarithms base 2. Okay. Now this first term here, I can expand that out as the sum of 2 different logarithms base 2. And finally, I can use that exponent to constant property, and I can bring down those exponents to be coefficients of my logs. And this is what I get. Okay, so we can go both ways with this whenever we get these logarithm expressions. We can take one logarithm expression and we can expand it to be the sum or difference of multiple different logarithm expressions, or we can take a longer logarithm expression and we can simplify it to 1. One more example that I will do here, just to make sure that we can go both ways. I'm going to do 3 log base 2 of x plus 1/2 log base 2 of y minus log base 2 of z. Okay, so again, this time I have a much longer logarithm expression and I want to simplify it down to one logarithm expression. So going backwards on what we just did, I'm going to make each of my coefficients that I have in front of my log terms a power of the argument. So I'm going to have log base 2 of x to the 3 plus log base 2 of y to the 1/2. Remember, y to the 1/2 is just the square root of y, so you can also write it like that. I will do that in my next step. So now I'm going to combine everything that's added together. So that's going to be log base 2 x cubed multiplied by y to the 1/2 or the square root of y, whichever way you want to write it, minus log base 2 of z. And finally, I use that quotient property. I get x cubed square root of y divided by z. Okay. Finally, what I want to do here is to evaluate some log expressions. So where you have these longer log expressions, you combine them all down into one log expression, and then you can go ahead and actually solve it. Okay. So for example here, let's say I had log base 7 of 28 minus log base 7 of 4. Okay. Using my properties of logs, I know I can use the quotient property here. So that becomes log base 7 of 28 over 4, which is just log base 7 of 7. Okay. What's the answer to this? Well, it's asking what power do I have to raise 7 to get 7? Well, that's just 1. 7 to the power 1 is 7. So I know that the answer to this is 1. So simplifying these very difficult logs into 1 can sometimes really help us solve these particular log expressions. Another good example from the textbook. Let's say I had 3 to the power log base 3 of 5 minus log base 3 of 4. Okay. Again, very difficult expression, not sure what the answer is here. But first thing I would do is combine my logs in that expression. So I'm going to have 3 to the power log base 3 of 5 over 4. Okay. Now I can use my second inverse property. Okay. You'll notice that the base of my exponential is also the base of my log, which means that my solution is just whatever my argument is, being 5 over 4. Because remember, log base 3 of 5 over 4 is asking me what power do I have to raise 3 to get 5 over 4. Well, I'm raising 3 to that power, which means that I must just get 5 over 4 out of this expression. In the next video, we're going to look at solving type 1 and type 2 logarithmic equations. And that's where we will use a lot of these properties that we have discussed in this video.